Alright, hello Nulcom. Today's talk is Zero Day Up Your Sleeve Attacking macOS Environments. My name is Wojciech Reguła and I'm a head of mobile security at Securing, where I'm mostly focused on iOS and macOS application security. In my free time, I run a blog, wojciechreguła.blog, which is about, of course, Apple security. So if you are interested in this topic, feel free to visit my blog. Somebody of you may also know me from iOS Security Suite that I'm a creator of. It's a free, Swift, open source library that helps developers and security teams making sure that their mobile application is compliant with OWASP Mobile Application Security Verification Framework checks. And recently, we also started in Securing a new service that is macOS environment security testing. So let's go to the agenda. And before I'll introduce you to this talk, I had an idea in my mind before I started creating this talk that I'd like to give like typical red teaming talk, but red teaming talks are usually about Windows or Linux, but I wanted to give a macOS related talk to show you that all these techniques that you know from attacking Windows or Linux are also possible on Macs, that Macs can also be successfully attacked. All right, so we'll start from a quick introduction. Then we'll compare some different use cases of Macs in corporate environments. And then we'll start with setting up a C2 with Mavic, and then the standard red teaming procedure, that is initial access, persistence, data collection, lateral movement. And because I don't like leaving people without the recommendations, I'll talk a bit about hardening macOS environments and, of course, the conclusion. All right, so I have one question to you, or two questions, but that's the first one. Please raise your hand if there is at least one Mac in your company. All right, so it's like 90% of the audience, I think. That's good. So the second question, please raise your hand if that Mac has access to your company resources like other Windows machines. Okay, like I think like almost everybody who rose their hand during the first question rose their hand during the second question, which is good, but because it proves that my assumptions were correct. All right, so why did I decide to make this talk? Because Macs are getting more common in corporate environments. They are widely used by developers, UX, designers, managers, etc. In small companies or software houses or IT companies in general, those companies have a large percent of Macs in their environments. And those Macs are not symmetrically secured comparing them to Windows machine. I spoke some time ago with a person that works for a big international bank, and he told me, Wojciech, but we don't have any Macs in our environment. And I asked, do you really? I saw you have a mobile banking application for iOS. So how do your developers program it and build it and deploy it? And he said, okay, I will return to you with the answer on that. And after a couple of days, he told me, yes, actually we have a team, an iOS team that makes that application. And you know what? Our Macs are not even, Macs of the developers are not even enrolled to MDM or anything. You know, they bring their own devices that are a blind spot for their socks. So that was an interesting conversation. So what are the problems that we identified during many macOS environments assessments? So there were old and vulnerable macOS versions everywhere, like everywhere. We had one assessment when I audited all the Macs because it was a small company. And it turned out that the person responsible for finance in that company used Mac not updated for 3 or 4 years. And you know, Macs also have vulnerabilities, right? by default, macOS system firewall is disabled. So if there is nobody who force people to turn on their firewalls, especially non-technical people, the Macs probably will be left with the firewall disabled. And anti-malware, do Macs even have viruses? Unfortunately, yes. We have to care about it. Not even saying about standard users working on admin accounts. And I think that is common in some hardened Windows environments. Like this is lack of hardening whitelisting. Like whitelisting of applications is, of course, in the most hardened Windows environments, but I didn't see in all assessment that we did, I didn't see at least once corporate environment with the whitelisting on Macs. And in mid-sized companies, Macs are not even enrolled in MDMs, so that's really bad. There is no central mechanism to manage those Macs in mid-sized companies usually. Okay, so let's compare now three situations where Macs are present in corporate environments. So the first scenario is that Macs are directly bound to the AD. So there's a classic Active Directory environment with Windows machines. There are mostly Windows machines, and some of the developers, managers, etc. Use Macs, and those Macs are natively bound to the AD. But that's the most rare situation, to be honest, from my experience. The second one, a bit more common, is that, all right, so this company has an Active Directory environment. Those Macs are not bound to the AD, but they have somehow to access resources using the Kerberos. So there's an application, an extension called Nomad that handles Kerberos for you. So the user or the admin provides the AD credentials to Kerberos, to Nomad, and it generates the whole Kerberos communication. And the third one, observed in modern companies, is that there is no Active Directory, just one SSO, like for example Okta. And via this SSO, the person gets access to all the services used by the company that are, of course, in the cloud. So AD is not necessary in this scenario. Okay, but for this talk, we will focus on such an environment. So we will be attacking a Mac that via OpenVPN has access to internal company resources. It uses Nomad to talk to Active Directory, and then via Active Directory it gets access to Google Workspace or Jira Software. This Mac also uses AWS. There are tokens stored. Has a browser, in this case Firefox, that connects to Twitter, Facebook, or other social media, and that's usually a common case, especially for marketing teams, because usually marketing department works on their private account linked to the company account, and it's not really good to bound your private accounts to the company's SSO. So usually the connection to social media is out of Kerberos. It's out of SSO. It's a like typical connection to social media services, not via the company infrastructure. So there will be, for example, stored password for social media accounts on such a machine. And that company heard that Signal is a secure messenger, so we'll be attacking Signal on those Macs. And of course, there will be some secret data stored on desktop or other TCP protected directories. All right, so in order to perform this attack, we will be using Mythic. That's a really great red teaming framework with an extensive macOS support. It's open source. It's created by Cody Thomas. I really love Mythic because, as I told you, it's open source. It has really extensive docs, so it's really easy to set up. Not really common, so it's not really detected for now. Okay, so let me show you a quick demo. So we have the Mythic set up already. We'll log into Mythic. That's the main dashboard. We have one payload that is upfill, the standard one, and C2 profile that is HTTP. So let's create a new payload. It's really simple. Generate new payload. We select the operating system of the target, of course macOS in our case, upfill, the default one. We select all the comments that will be accessible. And we decide to use the simplest connection, that's HTTP, not the with the SSL. We provide the callback host. We click next, create payload, and now we can download it and use it to attack the victim. All right, but there are some problems on how can we get the initial access. So according to Apple, all the software downloaded directly with your browser or in general from the internet must be notarized. And it's the case for macOS applications, non-app bundles, disk images, flat installer packages. So most of the common stuff that executes your code on your machines, right? And what's that notarization? So notarization requires developers to have developer ID, the paid one, and to distribute their application. But before they can distribute their applications, they have to upload it to Apple. The application has to meet some requirements, the security policies, and it's verifying against the malicious code if there is some malicious code in those applications. But you may ask me, all right, but what happens if I don't notarize my application or my payload? So unfortunately, macOS will block it. There will be a prompt that no notarized app cannot be opened because the developer cannot be verified. So we have to somehow bypass it. So this is the talk. This is what the talk is. This talk is about. So let's find some solutions. We can, of course, buy a proper developer certificate, create a legit PKG file, notarize it, but we are risking our certificate to be revoked, right? So there is the second solution, commonly used by current malware. So we can provide our payload bundled in a DMG file. And DMG file is a disk image where we can set the background of. So as you can see here, that's an example of real malware. There is a background with an instruction to the victim on how to bypass their how to make the victim bypass their own security mechanisms, right? So the malware asks the user to right-click on the package, unsigned package, and click open, and there will be a prompt that the application was downloaded from the internet. It wasn't verified by Apple, so please click OK and risk your Mac hacked. And so that's the second idea. The third idea, because this talk is about 0 days, we can find a gatekeeper bypass. Gatekeeper is that mechanism that on macOS side verifies if the application was indeed notarized. So we can bypass it with a 0 day. I even found one 1 year ago, but it's fixed. And we have the fourth technique, and that's the technique you probably know from attacking Windows. That's a technique that involves Microsoft Word. On Microsoft Word, there is also macros, macro possibility attack. So we have a Visual Basic and the auto open subroutine, which will be executed after user opens the document file and allows macros. And in that subroutine, we can call MacScript that in the end will execute our bash commands. So in that case, I just download our payload created with Mythic, and I run it with also script. All right, so let's assume that that user downloaded it and clicked enable macros. The code has been executed, but the problem is that Microsoft Word is sandboxed. So even if we use that trick with macros, our remote shell will be not that cool because it will still run in a sandbox process context. So we can do a limited stuff on that machine. However, there is another bypass for it, made by Madhav that shared a really cool technique that allows us to escape Word sandbox. However, it requires the user to reboot their Macs. So it's good technique, especially when you know, for example, that Apple will push some updates and you can infect the machines right before that update. So you will be sure that most of the users, maybe if it's enforced, for example, will reboot their Macs, but it's not like 100% effective. We'd like to see something more effective. So we have our own 0 days, and I now present a macOS sandbox escape vulnerability. Unfortunately, it's not fixed, so I won't share you the actual code. So you have to trust me that this demo is real. All right, so this 0 day is for the whole standard macOS sandboxing mechanism. It's not only for escaping the word, but it's for the whole standard sandboxing mechanism. So let's see how it works. So the user clicks on the document file, clicks enable macros, and as you can see, we have now an active callback. We can now use it. I wrote shell, a command to the mythic, and now we can execute any shell command we want. So let's start with who am I. Reguła, that is my user. And now let's try with ls, the user's directory, which if succeeds means that we have unsandboxed code execution. Yeah, so we can see 2 users, which means that our code is now unsigned and unsandboxed, run by the victim. That's good. We have the initial access. Now let's talk about the persistence. So on macOS, there are a bunch of typical persistence techniques like launch agents, launch daemons, login items, cron jobs, and tons of others. My friend Csaba Filc documented it on his blog. So it's now like 27 or something persistence techniques documented, so it's quite a lot. But in this talk, we'll use the standard one. So we pass the persist launch to the command to the mythic. And now with the OSA script, the very same command that I used in the Word macros, we will be running the payload created by mythic, right? We can change the label to look more stealthy. And click task. Let's wait a while for the mythic to create the launch agent. As you can see, the file has been written. So now the second step, because now we registered the launch agent, but now we'd like to load it. And that's simple. We just take the path, again shell, launchctl, load, and that path. Click task. And in a while, you will see that we will have the second active callback. Yeah, the second one. So now we have unsandboxed, unsigned code execution on Mac with persistence, right? So even if the victim reboots their computer, we'll be still able to connect to that reverse shell. All right, a quick update. In macOS Ventura that will be released this fall, there will be a new tab in general settings that will show all the launch agents and launch daemons registered in macOS. So this technique will be not that stealthy anymore. However, as I told you, there are plenty of different techniques, and Apple covers maybe 3 or 4 of them in that vein. So just switch to another persistent technique. It's really easy to do so. Great. So we have taken over the Mac. Now let's focus on the data collection, right? So we are interested mostly in VPN credentials, AD credentials, signal messages, browser cookies, keychain entries, AWS or other cloud keys, and desktop and document files. Let's start with OpenVPN. So OpenVPN stores its profiles in application support directory that can be accessed without any additional privileges. Like standard macOS user can access it without providing any password. It's not encrypted. So if all the credentials required to establish a VPN connection are there, that's it. But usually the profiles don't store user login and password. So we have profile, but we still need to steal the user's login and password, right? Because of the notarization, applications have to have the hardened runtime turned on. So we cannot easily inject to those applications. However, on purpose, developers can disable some of the security mechanisms for their applications. And that's the OpenVPN does. It's another kind of zero-day. It has the 2 problematic entitlements. The first one is allow built environment variables, and the second one is disable library validation. So with that knowledge of those 2 entitlements, we can now inject our dynamic library inside of the OpenVPN context, and yeah, we can, for example, steal keychain entries that OpenVPN stores, or launch a keylogger inside of the OpenVPN. So why couldn't I use a global keylogger? Because on new macOS versions, if you'd like to register a system-wide keylogger, it requires a special permission from the user. There will be a prompt that the application wants to record all user input, and we'd like to avoid it. But if you are in the context of an application, you can get all the keystroke that user passes to the application without any additional privileges, because it would, don't have any sense to do so. It's expected behavior, right? So the application may catch the user keystrokes, right? So I created an open source keylogger that you can download from my GitHub. It's on Git. It's a really short code. And with the built insert libraries, we can inject to the OpenVPN and wait for the user logins and password. And that's how we can steal the VPN credentials from user. Again, it didn't require from us any additional privileges, like just standard user. Nice. So we have OpenVPN taken over. Now let's go to Nomad. And Nomad saves your Active Directory credentials in macOS keychain. And the keychain has a flow that allows getting entries from it without any prompt, root access, or user passwords. I documented it in my blog post, so if you are interested how did it work, feel invited to read that post. However, I also open sourced a Nomad credential stealer tool that will do all the job for you. So it's pretty simple. You just run the Nomad credential stealer application, and it will dump the Active Directory credentials right from the keychain without raising any prompt. Again, no additional privileges, standard user. So because we were able to get all of the credentials from the macOS keychain, we are now able to access all the company's resources that are hidden behind the ADF SSO, right? Okay, now let's torture Signal. Who thinks that Signal is secure? Raise your hand. Okay. I hope so as well, that Signal is secure. But the thing with Signal is that Signal claims that they protect your data only in transit. They don't care about your endpoint security. So all your messages on Mac from Signal are encrypted. There is a database, an SQLite free database that's encrypted. However, what about the key? The key is not stored in the keychain. It's stored in a flat file, accessible by a standard user. So you go to the library application support Signal config.json, you grab the key, pass to the SQLite database, and we have all your messages unencrypted. Yeah. So the next target is Firefox. So Firefox stores saved logins and passwords in an encrypted form. That's good. But if the master password is not set, that is a default configuration, the saved credentials can be dumped again without root. And personally, who of you uses Firefox? Okay. And do you have the master password set? No, nobody does it. So yeah, there is a tool on GitHub made by Unode that's called Firefox Decrypt. And I will show you a quick demo on how it works. So you run it with Python, select profile, and you're done. No additional privileges again. Great. So AWS and desktop and other protected resources are left. So let's now focus on the TCC. So whenever you install a new application on Mac that will require your camera access or screen share, so for example, maybe Microsoft Teams or Google Meet or anything, when the application tries to access those resources, those protected resources like camera, etc., for the first time, there will be a prompt. And that prompt is a protection of your privacy-sensitive data, and the mechanism behind of that prompt is called TCC. And now TCC protects a lot of sensitive resources like camera, calendar, Bluetooth, automation, contacts, network shares, photos, music, and many, many more. Even if you have that Mythic shell and you will try to, for example, do the list of desktop and click task, you will see that there will be a prompt, and if the user clicks don't allow, the operation will be not allowed. And the case is also for root. So even if you have root, you cannot bypass this prompt. Apple decided to make these prompts to be clicked by user with a clear intention. So it has to be done by user, even if there is a root account on Mac. It still that doesn't mean anything. You can bypass this prompt. You can't do this. However, there are tons of TCC bypasses. I was co-speaking last year ago on Black Hat in the US about 20 plus ways to bypass your macOS privacy mechanisms. But yeah, that would require 0 days. That those vulnerabilities are all now fixed. So we can try abusing other applications that are installed already on macOS, but applications that have the already permissions granted. So there is a problem with Electron apps. Yesterday, there was a wonderful talk about abusing Electron remotely. Now, that's a technique that allows abusing Electron locally. So if you are interested, feel free to read it. However, as I promised you to show some 0 days, this was a 0 day, but it was recently fixed by Apple, which is good. So there was a bug in launch services that allowed us to bypass the TCC. And I wanted to give you some insight on how this exploit worked. But unfortunately, I found a bypass for that fix, so I'm sorry. Maybe next time I will show the full exploit with the bypass for the fix. But I will show you a demo to not leave you without anything, right? So let's verify if this macOS is updated and secure. In that times, it was the newest macOS. The system integrity protection is enabled. We now verify that the application that bypassed TCC by me has no TCC permissions granted, so there's nothing for the bypass TCC by me app. Now let's open it. And there are 2 buttons made for the proof of concept reasons. We click steal address book, and as you can see, it's stolen. And still iMessage chat that, as you can see, is stolen. Now let's verify if everything succeeded. So we go to TMP, and with file, we'll verify if it worked. Yeah, file was able to load both of the databases. That means that we have bypassed the TCC. Okay, so we have our TCC bypass, but there is one more thing. With the TCC bypass, we were able to allow desktop, documents, downloads, and other protected resources. But what about the cloud keys, the cloud credentials? Good news for red teamers. They are stored in home directory, which is not TCC protected. So if you'd like to steal AWS or SSH keys or Azure G-Cloud or anything that stores their secrets in home directory, you don't even have to use any TCC bypasses. It's a directory that's not protected by the TCC. All right, so with all that knowledge, we were able to fully compromise the macOS machine. And because, as I told you, I don't want you to live without any recommendations, there are 6 points, the bare minimum you have to implement in your macOS infrastructure. The first one is enroll your company's Macs to MDM, maybe Jamf or Intune on any MD1 you like. Keep them updated, because as I proved on the presentation, that are vulnerabilities for macOS, so please keep them updated. Enforce security policies like system integrity protection. Without system integrity protection, TCC is not even in place. There are no checks. With SIP disabled, you can elevate your privileges to root without providing even a user's password. So make sure that there are policies that are unenforced. There is an interesting story, because for the last few years, when I was Googling for finding some example codes on macOS or something stopped working, I of course Googled for Stack Overflow, right? And in Stack Overflow, there are a lot of recommendations that claim, all right, so you can't run this application because there is notarization. So let's try disabling SIP, and maybe that will work. And there are so many answers on Stack Overflow that misguide users to disable system integrity protection. So you really want to be sure that your organization have security policies enforced. Disable office macros. I can bet that in most cases, if you have modern infrastructure and you have Mac users, they don't even use Word macros. On macOS, of course. On Windows, the finance department will probably use them, but most of Mac users, they don't use Word macros. So I bet you can disable it. Install an anti-malware solution, EDR or whatever. Macs have viruses, so they need to be protected. And monitor your Macs, because there is always something that may go wrong, right? If you'd like to verify if your macOS infrastructure or environment is secure, you can always hire us to do this. We can perform a red teaming for you, or just assess your environment. So you have a contact to me. And to sum up, that will be the shortest sum up ever. Please remember that Macs, like any other machines, have viruses, can be attacked, have to be updated. So please do it and stay safe. Thank you very much.
Does anyone have any questions?
Hey, great talk. So for the Word document that gets downloaded with the macro, would it get quarantined with the extended attribute flag? And I know there's bypass for that as well, but at least it's an initial defense.
So Word documents are not quarantined, even if they have the tag applied, because that would have no sense, right? Because you want to have apps quarantined, like images, like, of course, disk images, like packages, like applications, etc. That's what you want to have quarantined. But for example, PNG images or, text files, you don't want to have them signed, in order to open. So there is an allow list of extensions that don't have quarantine, and Word documents are one of those non-quarantined extensions.
One more question about the TCC bypass. I noticed Terminal had access to contacts. So I think it's relying on the attribution change of the parent process in the demo.
The terminal hack, but which one?
Had access to the contacts in the demo. So is it relying on like the parent process attribution chain?
No. It's the story behind this bug is really interesting, because I found it really accidentally, and I couldn't believe it worked. It's a part of mechanism that I think all of my friends researchers knew about that behavior, and even I knew about this behavior for maybe 2 years. And one night I was asleep and I was like, the idea stumbled across my mind. I said, wow, but that shouldn't be working right there. And I went to the computer and it worked. So that's really obvious bypass, but I can't, I'm sorry, disclose it today.
Does anyone else have any questions? Okay.
Hi. Amazing talk. Actually, in your sandbox escape technique, you discussed about the persist launch. I missed that point, like how it works.
The sandbox escape, the question was?
About the mythic persist launch.
The persist launch?
Yep.
That technique that was presented that required reboot was via login items, but my sandbox escape, that's not what I can disclose about the details regarding this technique. But yes, there is something with LaunchD, but I'm not saying anymore.
Okay.
Anything more.
All right, nice. Thank you.
Thanks for the talk. So my question is around the mythic attack that you showed.
Could you speak a bit louder?
The mythic technique that you showed, wherein the word macro was used. So you used a sandbox escaping technique, right? So
Yes.
were you also able to do anything interesting without sandbox escaping? Like
So with Sandbox turned on, you could be able to access only those resources that are available to Word. So it's not really much. You can make connections. You can establish a shell with the machine, but it's not really worthy. If Word has access to some resources, like, I don't know, camera, that's a rare case, that would be maybe worth something, but in most cases, you will need to have an unsandboxed code execution.
And another follow-up, so have you also seen similar attacks in production, like in the wild, being exploited?
Once again?
Have you seen similar attacks being exploited in the wild? Or is this something?
Such exploits with Word, right? Yes.
Okay, thanks.
Any other questions from the back? Okay.
First of all, thanks for the talk. It's really fantastic. So I have a doubt related to disabling the SIP. Is it possible to disable the SIP through the tool you showed?
In order to disable SIP, you have to reboot your Mac. So no, not from the. Maybe if you have a 0-day, yes, but there is no standard technique to do this without having a vulnerability. You have to reboot your Mac to do this.
Okay, thank you.
Any other questions?
So in the organization, some part I have seen when you have to connect critical environment, so they do allow the developers will still be using Mac machine, but when they have to connect to the production environment, they were using some sort of VDI to connect back to the corporate environment.
No,
so that's where I see that there is a gap, like metrical security controls are not deployed on those Mac devices because they are not directly connecting to the corporate or to the production environment. So is that something you see reasonable, or do you think, okay, there are bypass over the VDIs that can lead to compromise or like someone can get into your crown jewels or your production environment?
It really depends, but the answer would be really long for that question. So maybe let's do it after, okay?
Sure.
Any other questions? Okay, thank you. So thanks again, Wojciech. Thanks a lot. So the lunch break is going to start in 1 minute from 12:45 to 2 p.m. and we'll see you again. Thank you.